1 minute ago, sensors at Campi Flegrei triggered the highest pressure spike ever recorded, 38 megapascals in a single burst. Scientists say, "We've never seen this before." 500,000 people are living atop a caldera now swelling like an overfilled balloon, its magma chamber jumping in volume by almost 2%. If this invisible force breaks the rock, it won't just reshape Italy, it could flip every eruption model we thought we understood. But what does this sudden inflation actually mean, and how close are we to a disaster no model predicted? At exactly 1432 UTC, the Osservatorio Vesuviano's dashboard lit up with a set of numbers that stunned the scientists on duty. Pressure in the Campi Flegrei magma chamber surged to levels never captured before in the observatory's digital records. The system clocked a spike that, when calculated, put the internal force at nearly 38 megapascals, 4 times higher than the worst days of the 1980s crisis. Within the same hour, GPS stations across Pozzuoli and the caldera's core registered a sudden ground uplift of 4.2 millimeters. That might sound small, but in volcano science, it's a leap rarely seen outside major eruptive events. Over the last 12 months, the ground had crept upward by about 8 centimeters, but now the pace had shifted from a slow crawl to a visible jump. The cumulative rise since 2007 now stood at 1.33 meters, enough to tilt ancient columns and shift entire city blocks by the thickness of a brick. The numbers didn't stop at vertical displacement. Calculations from the deformation network showed the caldera's underground volume had expanded by nearly 1.8% in a matter of hours. That's the kind of swelling that, in theory, takes weeks or months to build. Instead, the chamber stretched and pressed outward as if the Earth itself had inhaled sharply. Every monitoring station in the red zone, from Rione Terra to Solfatara, confirmed the anomaly. No single instrument failure could explain it. The readings matched across independent networks, GPS, tilt meters, and remote satellite passes. Duty scientists, glued to their screens, ran cross-checks and reboots, suspecting at first a calibration error. But the data held steady. Each minute brought a new confirmation. The ground was rising, the pressure was climbing, and the system was not relenting. The rapid-fire alerts triggered internal escalation protocols. The team logged every reading, time-stamped each anomaly, and began drafting the first technical bulletin before the hour closed. For the scientists on shift, the numbers told a story louder than any alarm. This wasn't a routine fluctuation. This was a surge that broke every local benchmark, a raw, undeniable signal that something deep beneath Campi Flegrei had changed in real time. Underground, the magma chamber is behaving like an overfilled balloon. As new molten rock pushes in, pressure builds, stretching the dense volcanic rock above it. At Campi Flegrei, this pressure doesn't just lift the ground by fractions of a millimeter, it brings the entire caldera closer to its breaking point. When the force inside the chamber rises faster than the rock can bend or crack, the risk isn't just theoretical, it's mechanical. The rock acts as a lid, but every new surge means it's being tested again and again for its ability to hold. This isn't an abstract process. The ground swelling beneath Pozzuoli and the western edges of Naples is the direct result of magma forcing its way upward, inflating the surface. Scientists call this bradyseism, but for people living in the red zone, it means floors slanting, doors jamming, and cracks snaking along walls. The analogy holds. If a balloon fills too quickly, it doesn't just stretch, it pops. The faster the pressure climbs, the less time the rock has to flex, and the greater the chance it could fail suddenly. That's why speed matters. Campi Flegrei's crust has handled decades of slow inflation, but the current pace is something different. Professor Giuseppe De Natale, a leading volcanologist at INGV, has compared the present rate to a sprint, not a marathon. Each hour of rapid inflation means the caldera is moving closer to the critical threshold where rock strength gives way. In the past, pressure increases unfolded over weeks or months. Now the system is forcing these changes in mere hours. The consequences of crossing that invisible line aren't limited to geologists' models. They're lived by the 500,000 people who call this ground home. Families in Pozzuoli describe nights punctuated by tremors, with furniture rattling and car alarms triggered by the shaking. On social media, residents share videos of light fixtures swaying and objects tumbling from shelves. Many remember the Bradyseism crisis of the early 1980s, when thousands left their homes, some never to return. Today, those memories are mixing with fresh anxiety. Younger adults pack bags just in case, while elders debate whether this time is truly different. One resident put it simply, "We didn't sleep last night. We don't know if we'll sleep tonight." The human stakes are impossible to separate from the science. Every millimeter of uplift is a signal that the pressure inside Campi Flegrei is searching for release. With 500,000 lives in the red zone, the speed of the current spike transforms a geological event into an immediate, personal risk. The next sign of what's happening beneath their feet will come from the way the ground and the rocks respond, whether by more swelling, by a swarm of earthquakes, or by something no one wants to imagine. The ground beneath Campi Flegrei didn't just rise, it fractured. In the hours after the pressure spike, seismic stations across the caldera began logging a swarm unlike any in recent memory. Over 150 earthquakes rattled the region in less than 6 hours, with the largest, a magnitude 4.4 event, striking at a depth of just 2.6 kilometers under the Solfatara crater. This wasn't a single jolt, but a relentless barrage, each tremor a sign that the crust was struggling to hold back the force building below. Most of these quakes clustered northeast of Pozzuoli, directly beneath the neighborhoods that have seen the fastest ground uplift and the sharpest gas emissions. The epicenters mapped out a dense cluster, tracing the outline of the caldera's most fragile zones. For scientists, this pattern is a red flag. When earthquakes bunch up at shallow depths, it means the rocks above the magma chamber are cracking, shifting, and sometimes even opening new pathways for heat and gas to escape. Seismographs recorded not just the headline events, but a constant undercurrent of microquakes, hundreds of tiny fractures per hour, too small to be felt but unmistakable in the data. The audio traces from these instruments painted a picture of a crust under siege, with waveforms stacking up in rapid succession. Each one a warning that stress is redistributing through the volcanic system. The swarm's intensity and concentration set it apart from previous crises. In the 1982-84 Bradyseism episode, swarms would build over days or weeks, but now the pace has accelerated to hours. The frequency and magnitude of these quakes have exceeded anything logged since modern monitoring began. Depth matters as much as number. Most of the seismicity during this spike has been shallow, centered between 2 and 3 kilometers below the surface. That's precisely where the brittle cap rock sits, acting as the last barrier between the magma and the city above. When pressure breaks through this layer, the risk of new vents or surface disruptions increases. The largest quake, at magnitude 4.4, was strong enough to rattle windows and set off car alarms in the heart of Pozzuoli. Residents reported feeling multiple shakes in quick succession, with some describing the sensation as a rolling wave moving through their homes. Scientists used cluster maps to visualize the swarm in real time, watching as the red dots stacked up along known fault lines and new fracture zones. The data provided instant validation. The crust was responding directly to the pressure surge detected earlier in the day. Each tremor, each crack, was a mechanical answer to the force building below. The swarm's spatial pattern matched the areas of greatest uplift and highest gas release, tying the seismic activity to the same underground processes inflating the caldera. The sound of the swarm, captured as a continuous low rumble on seismographs, became the audible evidence of a system in motion. For those monitoring the instruments, it was impossible to ignore. Every spike on the trace, every cluster on the map, was a sign that the ground itself was broadcasting the story of what was happening beneath Campi Flegrei, second by second. Confirmation of the spike came from every corner of Campi Flegrei's monitoring network. More than 24 GPS and tiltmeter stations, some perched on apartment rooftops, others drilled into the volcanic hillsides, all reported the same surge. Within minutes, satellite radar, known as INSAR, delivered images showing the ground had shifted in a broad, unmistakable arc from Pozzuoli to the rim of the caldera. The 15 million euros invested in this sensor web paid off. No single glitch or outlier could explain away the numbers. Each system, using different technology and data paths, told the same story. The caldera was inflating faster than at any point in the last half-century. The network's value became clear again at Solfatara, Campi Flegrei's most active crater. Gas analyzers picked up a dramatic spike in carbon dioxide, up 32% in just 24 hours. Sulfur dioxide, the sharp-smelling marker of magma, also climbed above normal. Fumarole temperatures, already among the hottest in Europe, jumped from 162 to 187 degrees Celsius. Residents in the surrounding neighborhoods reported a thickening haze and a biting chemical tang in the air. These aren't just background fluctuations. In previous crises, such as the 1982-84 Bradyseism, gas surges of this scale only appeared after months of steady unrest, not hours. Now, the timeline has collapsed. Field teams compared the current readings to the historic benchmarks. During the 1982-84 crisis, the ground in Pozzuoli rose 1.8 meters over 2 years. That episode triggered the evacuation of 40,000 people and more than 16,000 earthquakes, but the signals then unfolded gradually. In February 2024, a swarm brought a 12% jump in gas emissions and more than 1,000 quakes in 3 weeks. Today, the pace is compressed. Ground uplift, seismicity, and gas output are all rising together, and at rates that took months or years to reach in the past. The data is relentless. INSAR images show the central caldera bulging outward in near real time. GPS logs tick upward with every new reading. Gas charts spike sharply instead of climbing in slow, rolling waves. Scientists have run every cross-check, calibration logs, maintenance records, even battery voltages. The instruments are working. The numbers are real. This is not a drill or a false alarm. Each independent line of evidence circles back to the same conclusion. Campi Flegrei is experiencing an acceleration that stands apart from anything in the modern monitoring record. The crisis is no longer a single-discipline anomaly. It is a multi-sensor, multi-parameter event, with every key metric flashing red at once. Against the yardstick of Campi Flegrei's turbulent history, today's spike is rewriting the playbook. The tools built to catch the next big event are now capturing it in real time, leaving little doubt that the system beneath Naples and Pozzuoli has entered a phase that scientists and residents have never witnessed before. Scientists now face a set of possible futures for Campi Flegrei, each shaped by the signals pouring in from beneath the caldera. The first possibility, still considered the most likely by many experts, is that the system will release pressure gradually through continued earthquakes and ground deformation. In this scenario, the crust absorbs the stress, cracks relieve tension, and the volcano enters a period of uneasy stability. This is what happened during the 1982-84 crisis, when thousands of tremors and slow uplift eventually settled without an eruption. A second scenario involves magma rising into new cracks, but failing to reach the surface. This process, known as magma intrusion, can keep seismicity and uplift elevated for weeks or months, but the magma stalls before breaking through. The system remains restless, with persistent earthquakes and ground swelling, but no eruption occurs. Scientists point to past episodes where intrusive events produced months of anxiety and disruption, yet ultimately spared the region from a major blast. The third, least likely but most serious outcome is rapid escalation toward eruption. If pressure continues to climb and the rock above the magma chamber fails, an eruption could follow, either as a sudden steam-driven explosion or a true magmatic event. The last time this happened was in 1538, when Monte Nuovo erupted after a period of intense unrest. While current data do not confirm this path, the unprecedented speed and scale of the present spike mean it cannot be ruled out. No official numbers are assigned to these scenarios. Instead, scientists stress that these outcomes are actively monitored and can shift quickly as new data arrive. The uncertainty is real, and so is the need for constant vigilance. Civil Protection Headquarters remains at yellow alert. This status means heightened monitoring, not evacuation, but every official knows how quickly that could change. The protocol calls for continuous data review, with technical teams reassessing the situation in rolling cycles, sometimes as often as every few hours when the metrics are this volatile. In the latest emergency meeting, Dr. Mauro Di Vito, director of the Osservatorio Vesuviano, stressed that the current deformation and seismicity patterns require maximum vigilance. He told colleagues and the press, "We have never seen this rate of change in all our years of observation. We expect further events, but cannot predict their timing or scale." Behind the scenes, the logistical reality is daunting. Recent evacuation drills exposed traffic gridlock on the main arteries out of Pozzuoli and Naples. Simulations showed that even a partial evacuation could leave thousands stranded if signals are delayed or if families hesitate to leave. Reports from the last drill highlighted shortages of buses, limited shelter capacity, and communication gaps for non-Italian speakers and people with disabilities. Civil Protection's own after-action review called the system robust on paper, but untested for the speed and complexity this crisis could demand. Authorities are now reviewing risk every few hours, not waiting for routine weekly bulletins. They have not issued an orange alert, but the public is urged to stay ready for updates at any time. The next 48 to 72 hours will be watched with particular intensity, though officials caution that there is no fixed window for escalation or relief. Residents in the red zone are being asked to report what they feel and see. Every local observation helps refine the official picture. As new data arrives, another bulletin could come at any moment, and the chain of response will reset again. At 14:32 UTC, monitoring stations at Campi Flegrei recorded a ground uplift of 4.2 millimeters and a rapid spike in magmatic pressure, an event unmatched in decades of observation. Scientists confirmed 152 earthquakes in just 24 hours, and gas emissions at Solfatara crater surged by 32%, with vent temperatures reaching 187 degrees Celsius. This combination of ground deformation, seismic swarms, and gas release surpasses the pace seen in the 1982-84 crisis. Despite these unprecedented signals, authorities maintain the alert at yellow, and the next 48 to 72 hours remain critical as experts evaluate incoming data. Civil protection protocols are in place, but the speed and scale of this episode leave key questions open. How long will the pressure escalate, and can current models predict what comes next? What is certain is that 500,000 residents live above one of the world's most closely watched calderas, and every minute new data shapes the decisions ahead.